This is section 6.1, comparing two proportions. Okay, so you can look at the objectives in the comic there. What we want to do in this chapter is we want to learn how to compare two proportions. So for this example, we have a study where researchers recruited 30 subjects aged 18 to 65 with a clinical diagnosis of mild to moderate depression. Subjects were required to discontinue any use of antidepressant drugs or any kind of therapy for 4 weeks prior to the experiment and throughout the experiment. So these 30 subjects then went to an island off the coast of Honduras where they were randomly assigned to one of two treatment groups. Okay. So when I see that they are randomly assigned, I want to highlight that. Remember later it was randomly assigned. Both groups engaged in the same amount of swimming and snorkeling each day, but one group, dolphin therapy, did so in the presence of dolphins and the other group did not. Now it says here that neither set of subjects knew that the study was evaluating the effects of dolphins. They didn't know there was another group, they just thought that they were there to go swimming and snorkeling. Okay. So why do you think they put that in? I think they put that in to tell us that the study is going to be blind, which we'll talk about in a minute again. At the end of 2 weeks, each subject's level of depression was evaluated, as it had been at the beginning of the study, and it was determined whether or not they showed improvement, so whether or not their depression was reduced by the end of the study. We want to determine whether the group that swam with dolphins was significantly more likely to show substantial improvement than the group that swam without the dolphins. So we haven't been going over the 6-step process for every problem just because it takes a lot more time, and I'm trying to teach you each of the new topics. But let's pause here and let's do the entire 6-step process. Because in practice, we do the 6-step process anytime we do any study. It's just not always written out in these specific 6 steps, but you have to do this process for every study. So step 1 is ask a research question. So what is the research question that we are talking about right now? We want to know whether swimming with dolphins improves depression. Step 2 is design a study and collect data. Now we do all this designing before we ever see any of the data. Okay. So first thing we'll ask is what should we use for our experimental units? These would be the individual people. What is the explanatory variable? What are the groups that we put people in? We put them in dolphin or not dolphin groups. So the explanatory variable is whether or not they swim with dolphins. And then the response variable, we said we wanted to check to see whether they showed substantial improvement. You can see right here. Whether they showed substantial improvement in the depression. So my response variable is whether or not their depression improved. So they designed the study as described above. Is this an observational study or an experiment? So remember, what's the difference? It is an experiment because the researchers chose who was in each group. So observational studies, we just watch, we observe, we don't do anything to the subjects. Okay, the experiment, we actually put people into groups. And we did use random assignment. Okay, it doesn't have to be random assignment to an experiment. It should be. Random assignment is always better, but experiment just has to be the researcher shows who is in each group. And we use random assignment as an extra bonus, if you will. Oh, sometimes I forget what questions I asked, even though I read through this right before I did it. Okay, did they have a random sample? So go back up and look. Did it ever say that they found a random sample? Okay. I don't think it says anything about a random sample. It just says they recruited 30 subjects. Okay. It doesn't sound like it was a random sample. So I'm going to guess that no, they didn't have a random sample. But did they use random assignment? Yes, they randomly assigned people to groups. Okay. Is the study blind? Okay, remember how they said that people didn't know they were there to swim with the dolphins, that people were evaluating dolphins? So it's not like we actually blindfolded them or gave them a placebo, but we didn't tell them that the study had anything to do with dolphins. So both groups just thought they were there swimming. So both groups thought the same thing. So the study was blind. Okay, so it was blind because participants didn't know which group they were in. Or in other words, they didn't know that there were groups, so they can't know which group they were in. Okay. But is the study double-blind? That means that researchers, the evaluators, don't know which group the participants are in. And if you go back up and read, it doesn't say anything about whether or not they did, so I would say that we don't know. We like the studies to be double-blind so that the people interacting with participants don't accidentally give something away, or they don't evaluate them differently, or they don't treat them differently. Okay, let's see. Then they actually collected the data. So there were 15 people in each group. There were 10 people in the dolphin group that had reduced levels of depression, and there were 3 people in the control group that had reduced levels of depression. What we're going to do when we have two proportions, we will fill in a two-way table with our data. Okay. So you have groups here as the columns, you have different groups as the rows, okay, and we need to figure out how to put the data in from what they gave me. So it says there were 10 people in the dolphin group that had reduced levels of depression. So if I go to the dolphin therapy and improved, I'm going to put the 10 people. So 10 people in dolphin therapy that improved. Let's see, it also says there were 15 people in each group. So dolphin therapy had 15 people total, and the control group had 15 people total. Now it says there were 3 people in the control group that had reduced levels. So I go to control group, improved, and I put the 3. Notice this is all that they give me, but this is all that I need to fill out the entire table. So now if I know the dolphin therapy group, there were 15 people total and 10 improved, then how many people did not improve? It would be 15 minus 10 equals 5. So I would put in a 5 there. And same thing, if there's 15 total in the control group and 3 improved, that means there were 12 that did not improve. And then to find the totals, I just add everything up. So like 10 plus 3 is 13. 5 plus 12 is 17. 15 plus 15 is 30. A way to double check your work is to say, well, 13 plus 17 is 30. 15 plus 15 is 30. Make sure your totals line up whether you go across the rows or columns. Now this is called a 2 by 2 table because there are 2 rows by 2 columns. And we say by. We don't say times, we just say by. So it's a 2 by 2 table. We don't count the totals when we're looking at the size of a table. Step 3 is to explore the data. So we can use what's called segmented bar graphs or mosaic plots to compare our 2 categorical variables. So a segmented bar graph shows conditional proportions for each group, and those let us quickly compare the proportions for each group. So coming down here to this graph, this is our segmented bar graph. They just didn't put that into the applet, and I'll show you how to do it in the applet in a minute. But I want you to look at it. So this is our dolphin group. This is our control group. You can see that about 66.7% of the dolphin people improved. And then you can see that about 20, if I go across here, about 20% of the control group improved. Now that's interesting, right? Those seem like very different numbers, okay? 66% of people in the dolphin group improved, but only 20% of people in the control group improved. That does seem very different. For the mosaic plot, it's very similar, but what they do is they make the widths of the bars proportional to the sample size for each group. So this is the mosaic plot here. And now you can see that they make my bars wider. Okay, but these two seem like they're exactly the same width, and that's because we had 15 people in each group, so my bars are exactly the same width. So it's not very impressive to do a mosaic plot when your groups are the same size. But if one of my groups was a bigger size, then my bars would be different, and it just kind of helps us visualize the data. Okay. It still tells us, though, that 66.7% improved in the dolphin group and 20% improved in the control group. So both show you the same thing. Mosaic plot just lets you visualize the different sizes of the different groups if they have different sizes. Let me show you how this works in the applet. When you come to the applet, you want to go to categorical and to proportions. And now you enter a table. So in this chapter, we're only doing 2 by 2 tables, but you could do different sizes of tables for other future things that we learn about. Okay. And you come in and you put things in to this. So we need to put in the names of our groups. So we'd put dolphin and then I put control and improve, and I put in my data, so I'll put in 10, 3. Now here I need to put not improve. If I put in a space, it won't work. Do not do spaces. Or if you get an error, check and see if you have spaces in your names. If it just does not like spaces. Okay. Now, when you put all this in, double check that all of your totals match. 15, 15, 13, 17, 30. Okay, that's what I expected. You have to actually click use table. Okay. And now it will show you, here's the bar graph. If I want, I can switch to a mosaic plot. There's a lot of other things to do in here, and we're just going to show you kind of piece by piece as we go throughout the chapter. But I do like to click show table, and it will show me, here's the table. Okay. And it will also give me, here's my proportions, okay, which is pretty nice. You can change various things, like we were looking at the people that improved, but maybe I wanted to actually look at people that didn't improve instead, and you can make that your success. Lots of different things that we can change. Don't forget though, you have to click use table, and then I always like to click show table so I can see this down here. But back to actually looking at them. So let's think about it. If dolphin therapy does work, we would expect the bar graph to look like what? Or maybe let's start with, if dolphin therapy does not work, what would you expect the bar graph to look like? So if dolphin therapy does not work, wouldn't you expect these proportions to be about the same? Wouldn't you expect like whatever the proportion is to be the same in each group? So if dolphin therapy does not work, we would expect the bar graph to look like the same proportion in each group. So that means if dolphin therapy does work, we would expect a higher proportion in the dolphin group, which is what we see here. So, and the data looks like that. Okay. Much higher proportion in the dolphin group. So we are going to practice finding conditional proportions a lot in this chapter. So let's find what proportion of people in the dolphin group improved. Okay. So you come up here to the dolphin group, and you say there were 10 people that improved out of a total of 15, which if you put that in a calculator, you get 0.66666666. Okay. Notice though, that show table that I showed you in the applet, when you go to your applet and you click show table, it gives you the proportions right here. So you can still practice finding them by hand, but you can put them into the applet too to double check your work, and it'll tell you the proportion is 0.667. Okay. Or what proportion of people in the control group improved? Well, you come up and you only look at the control group and you say there were 3 people that improved out of a total of 15, which is 1/5 or 0.2. Notice that's the proportion. It gave you the proportion right there. So it will tell you the proportions. Okay. Now, just based on these proportions, do you think that dolphin therapy is associated with improved depression symptoms? So I am saying associated right here, because associated just means there's some relationship. I'm not going to try and say cause and effect yet. Maybe we'll talk about that later in the problem. But we want to know, like, is there at least some kind of relationship? Okay. Well, based on these proportions, I would say yes. So I'd say yes, because different proportions in each group. So I think that dolphin therapy is maybe not actually doing cause and effect, because we haven't gotten to where we're going to say that yet, but I think it's somehow related with improved depression. Now, the proportions that improved in each group do seem to be different, but how different are they? Is that a significant difference? Could that difference have just happened by chance based on who we put in each group, even if dolphin therapy didn't do anything? Okay. So what we need some official ways to compare the conditional proportions in the two groups. So the first one we could use is the difference in conditional proportions. So we can subtract the two proportions. So we're going to use some notation. And I didn't write it with official notation up here. So let's do that here. So this would be p hat for the dolphins. And you can write out the whole word dolphins, or you could just write a D. Okay, and this would be p hat for the control group. So this is my sample proportion for the dolphins. This is my sample proportion for the control group. So now if I want to subtract those, I'm going to write like this. I'll do p hat for the dolphins minus the sample proportion, p hat, for the control group. So for the dolphins, it was 0.667, and then I minus the proportion for the control group of 0.2, and that gives me, sometimes you're like, she didn't need a calculator for that, 0.467. So that is the difference in the proportions. Now coming back to the applet, I want to point out right here, notice it says observed difference in proportions, improved. When it says improve, it's saying like we looked at the people that improved, not the people that didn't improve, was 0.467. Okay, so that's what we got here when we did it by hand. And we're going to learn what to do with that number, but for now we just practice finding that number for this section. Or we can find something called relative risk. So both of these are valid. One is not better than the other. For the rest of the chapter, we're going to spend a lot more time doing the difference because it's a little bit easier to teach mathematically. Okay? But anything we can do with the difference in conditional proportions, we can also do with relative risk. Okay? Relative risk is very popular in medical sciences. You'll see that all the time if you read any of their journals. So for relative risk, we divide the two proportions, and then we call it relative risk. So we'll do the sample proportion for the dolphins over the sample proportion for the control group. So we'll do 0.667 divided by 0.2, which gives me 3.335. Now I do want to show you, coming back to applet, you can practice doing all these by hand. You should practice doing all of them by hand, but it's good to double check your work on the test. So right here it says statistic, difference in proportions. It told me that my difference was 0.467. I can switch to relative risk and now say observed relative risk is 3.333, which is what I got here. Just a little bit different depending on how you round. Okay. But what does relative risk mean? What that means is, so if you think about it, saying the proportion or the probability of improving in the control group was 0.2, the probability of improving in the dolphin group was 0.6. So that means you are about 3 times more likely to improve in the dolphin group. Okay. So we can think about it as the dolphin therapy success rate is about 3.335 times higher than the control group success rate. Or you can think about it as like people are about 3.335 times more likely to improve with dolphin therapy than with the control group. That seems very big to me. This difference in conditional proportions, that's hard for me to wrap my mind around. But if you tell your roommate that's never taken stats, like, sure, people are 3 times more likely to improve if they swim with dolphins, they can understand that. Okay, that makes sense to us intuitively. So we like relative risk because it's very easy to interpret. Okay. At this point, all we're doing is kind of exploring the data. We don't know how to actually do anything else. We're going to learn that in the next couple sections to where we can see if our difference is actually significant or not. Step 5 is formulate conclusions. So it does appear that dolphin therapy helps improve depression symptoms based on all the numbers we looked at, like they were 3 times more likely to improve. Okay. Now, we can cautiously say that we have cause and effect because we had random assignment to groups. But can we generalize our results to all people with depression? The answer here would be no, because we did not have a random sample. Okay. So we can only generalize to people that are similar to the people in the study. Now, we'd have to go back and really look at the study and say, okay, what kind of people did they have in the study? Is that different than other people? And kind of figure out who we can generalize to. But if we want to be able to generalize to all people with depression, we need a random sample from all people with depression. But that would be pretty hard to do because where are you going to get a master list of everyone in the US with depression or everyone in the world with depression and randomly sample from them? That is really hard to actually do. Okay. Let's see. Step 6 is look back and ahead. Okay, this is where we say, what can we do better? So this would be a better study if we use the random sample, but again, that would be really hard to do. Or we can maybe try a bigger sample. Now you might ask, why did they only do 30 people? That's not very big. And when we learn about our theory-based approaches, it's not even big enough to do a theory-based approach. Okay, but if you think about it, why would they do such a small sample? Well, it would be really hard to find people that fit your requirements for the study because you had to find people that are depressed enough to be clinically diagnosed. But they also have to be willing and able, like safely, to go off their depression meds for the couple months. They have to be willing to leave their lives behind and fly to Honduras for a few weeks. It's hard to find people that can do that and are willing to do that. And it costs a lot of money to fly people to Honduras and house them and feed them. So it is hard to do a big sample. And someone else might ask, well, is it just dolphins or does it work for all animals? It's a lot cheaper to just give someone a cat or a dog than it is to take them swimming with dolphins. So maybe you could try other animals. In summary, when we have two categorical variables, we summarize the data in what we call two-way tables. They're called that because they display data from two categorical variables. They're also called contingency tables. The size is always read as number of rows by number of columns. Okay, remember, don't count totals. There isn't a rule about whether the explanatory variable should be on the rows or columns. So you'll see tables do it either way. And I forgot, I actually like to, on each table, so I write on here and then I say, okay, dolphin therapy and control group, that was my explanatory variable, EV for explanatory, and improve versus didn't improve was my response variable. Now I understand you guys are doing homework on the computer, you're doing tests on the computer. It will help you a lot if you just take the time to hurry and sketch this table, like put it on a piece of scratch paper so you can do your calculations on the scratch paper. You can look at it visually, you can actually label it. It just helps a lot if you actually do more work on the paper. Let's see, we summarize the data visually with segmented bar graphs or mosaic plots. Segmented bar graphs will show the conditional proportions for each group, but mosaic plots, they're like segmented bar graphs, but the widths of the bars are proportional to sample sizes. And this was a really bad example to show you that with, because the sample sizes were the same. So let me just change this quickly. Let me say this was like 24, this was 6. We'll keep our proportions the same. Click use table. So notice now I made the control group twice as large. Notice when you look at the mosaic plot that the width of this bar is twice as large. Okay, so mosaic plots show you same thing as the segmented bar graphs, but it shows you that my sample size was bigger for the control group. There are more people in the control group because it is wider. And you can compare the conditional proportions with the difference in proportions. You just subtract the two proportions. Or you can look at relative risk, where you divide the two proportions. And if relative risk is less than 1, then that means the first group is less likely to get a success. If the relative risk is 1, then the groups are equally likely to get a success. And if relative risk is greater than 1, then the first group is more likely to get a success. Now this section is very short. We didn't learn how to do very much in this section, so I highly suggest that you take the time, start on the explorations, start on the practice homework, work ahead today because the other sections will be longer.